I'm Anil Kumar. Welcome to our series on algebra. Today we will learn how do we solve inequalities. Well, in the previous class we learned about writing and solving equations, correct? We are going to use those strategies to solve inequalities, and we'll also understand how are the two different. That will make our things very simple. So with the foundation of equations, we are moving on to inequalities. In between, there are some differences, and we'll fill this gap during the lesson and move forward. We are going to understand what are linear inequalities, and when we solve inequalities, we actually get not just one or two solutions. We get infinite solutions. We get a range of solutions. Now, in that range of solutions, do we have a zero? That helps us to test whether the solution is correct or not, and therefore we call it a zero test. It is a very important test. For example, as you can see in this figure, there is a parabola shown in green, right? And if you want to see what values of this parabola are less than 0, in that case the shaded region shown in orange is the solution. And this solution can be written as between these 2 points, right? So we can say these points are part of our solution. How do we know that this solution is right or wrong? So we can know with zero test. So we see whether the zero is in our solution or not. And when we draw, is zero a part of solution? Well, if that is the solution, zero is definitely a part of our solution, and therefore we can say, well, this is correct. So I hope you got it. But we will see how to use this zero test as we move forward. Just as in algebraic equations, we were writing those equations from verbal statements. Now, verbal statements are strictly speaking the word problems, which most of the time we are scared of. So, we'll once again practice how do we write these verbal statements as an inequality. Perfect. That is, we'll understand strategies to solve word problems, right? So, whenever we say verbal statements, it really means picking up the key phrases from the word problem and translating them into mathematical language. Earlier, we learned how do we write expressions and equations, and now we will see how do we write inequalities. Well, the key word in inequalities will be more, right? If you have more or less than or at least, so such words in a verbal statement signify that we are talking about something like greater than, right? Less than. At least means, at least is very typical. At least 5. That means we should have 5 or more, right? So we say greater than or equal to. So these are very important symbols to remember. So this means greater than, right? This means less than. And this means greater than plus equal to, both. So for example, we will say 7 is greater than 5, correct? We'll say 3 is less than 7, perfect? Greater than equal to means we say if number, let me write it here, A is greater than equal to 5, it means it could be any number after 5. Do you see that? On this particular graph, greater than equal to will be something beyond. Do you see that? That is greater than equal to. But when we say equal to, we fill in that whole, including the point. You get the idea. We'll learn this also. So I hope you have understood this concept of writing verbal statements into inequalities, right? It is translating those phrases into mathematical statements, and these statements will not have this time equal to sign. They will have combination of greater than and less than sign, right? And with them, equal to can come. Greater than, less than, equal to, right? Greater than or less than equal to. They can have a combination. Then we'll talk about compound inequalities where we'll use AND condition. Now this AND condition could be used in two different ways. We'll say one inequality or in many. So that makes things very complicated. Similarly, we'll also talk about inequalities with OR condition when we have one inequality or we have many inequalities, right? That is very interesting. Now, while solving these, we are going to use strategy of interval test. Just as I introduced you to zero test, that was a very simple quick test to check your answer. Interval test is to get the answer, right? So this is basically to get the solution, right? To get solution. And that test is to check solution. So you're getting, I hope, a gist of what we are going to learn. So this particular page is actually a very important page. You should look at it carefully so that you understand what are we going to learn today, right? Now, moving forward, we'll take some double inequalities. Means we could have some value which is greater than something but less than that. So that is kind of a double inequality in a particular linear kind of an equation. Instead of equal to signs, we'll have two different places with inequality signs, right? Okay, so that is the first part of our learning, but we'll introduce to you the second part of it, which is when some functions like absolute functions and quadratic functions are involved. Now, absolute functions and quadratic functions make inequalities very interesting. So we will begin with an example, but actually take up that example in the next session. Is that clear to you? So that will leave you with some thoughts. You can think about it over the period of time, and after a break, we'll take up absolute functions and inequalities in details. Well, in between, we'll have some practice questions and assignments to ensure that you have learned everything what has been taught today. So let's move on and explore inequality in today's journey. So as I was saying, we'll begin with linear inequality. When we talk about inequality, then the symbols which we see are not equal to. In fact, most of the time, we'll see these symbols, right? So we'll have to understand what does these symbols mean, right? So these are the symbols which we will see. What we are also going to see is how do we represent our information on a number line. For example, here I'm showing you two things. When we say that x is greater than equal to 2, it really means that 2 is included and everything which is on the right side of 2, right, is what we are looking at. This filled in circle which you see here means 2 is included. You get the idea. Perfect. And on the number line, when we are showing the solution, what are we really showing? We are showing solution on real numbers. So, by default, whenever we say that x is greater than something, then we are talking about real numbers, okay? So we are working in the domain of real numbers when we're talking about inequalities if nothing is specified. Perfect. Or sometimes in a word problem, we can make out whether it is a whole number, integer, or a real number, not just a whole number, right? we could figure this out. However, by default, it will be a real number. Now let's look into the inequality, which is x is less than 5. Now when I say less than 5, that equal to sign is missing. So do you notice this whole, right? Not filled in circle? That means not included. Perfect. So that is less than 5, and less than 5 means on the left side of a point. So on a number line, all the points on the left side will denote values which are less than, and on the right side it is greater than, right? So this side of the solution is greater than. So I hope now you understand what these symbols stand for, correct? Okay. In solving inequalities and equations, we'll see one major difference. And that is, as you can see from here, we have infinite solutions, right? As you can see, when I say x is greater than equal to 2, it means there are infinite numbers. There are so many real numbers, infinite, which are greater than equal to 2. Perfect. So there are infinite solutions for inequalities. Well, we could have inequalities with no solution also, correct? Right? So it could be from no solution to infinite solutions. There's a whole wide range of solutions, but in general, most of the time, we are looking into an interval which defines our solution. Is that clear to you? So we'll give you an interval. And this interval will use the symbols of inequality as shown here. Is that correct? Perfect. Another important thing is to note the difference between equations and inequalities. Will actually perform similar operations like adding same terms, dividing by same terms, multiplying by same terms. However, there is a very critical difference, and that is when a negative number is involved, right? Or when we are using in multiplication or division negative numbers. So that is very important. Since, see, 7 is greater than 5, correct? Now, if I multiply by minus, let me write here big and bold, that we know that 7 is greater than 5. How about minus 7 and minus 5? Well, minus 7 is on the left side, correct? Minus 7 is on the left side of minus 5. So in that case, minus 7 is less than minus 5. Do you see that? So what we did here, when you multiply or divide by a negative number, you have to flip the sign. So change sign of inequality. Is that clear to you? This is very, very critical. And therefore, I've written here as a caution. Multiplying and dividing an inequality by a negative number will also result in the reversal of the inequality sign. So is that clear to you? Perfect. Now with that, let's move forward and take some examples. Okay. Now let's actually, before really getting into the examples, once again understand what we talked about, right? So we'll again look into the inequalities on a numbered line. This is extremely important as the inequality solution is normally provided on a numbered line. And many times we are given a solution on a number line and we have to write the inequality. Either way, the number line gets involved. Second, number line is a very easy way of interpreting or understanding the concept. So therefore, we'll actually use number line in many places to understand what this inequality is, or what are we talking about? What is our solution really meaning? Perfect. So number line will be used in so many ways. Therefore, let us see how in our discussion today this number line and the inequality symbol gets related. Right. So I made a table here for you in which we'll talk about inequality in one column, describe it, and then show it on the number line. Perfect. So the very first one is x greater than equal to 2. As I said earlier, it means x is greater than 2. I should write here greater than, and x is also equal to 2. Both the things. So you could say greater than equal to. So this sign is for so x is greater than equal to 2. I should not use the word also, and then also very critical here. Or it is equal to, right? So it cannot be both the things at the same time. It cannot be equal to 2 and greater than 2, right? It means either one is perfectly fine for our solution. But the important thing here is that if it is equal to, we'll have a filled in circle, as I was saying, right? That is the one which shows that this is equal to. So the solution set shown in this fashion with filled in circle, like this is filled in, that means this is included too, and then everything on the right side. So that is what we are saying x is greater than equal to 2. Right? We use the word and, but literally we mean that x is also included and anything else on this side is included. Perfect. So the key word here, which is the filled in circle, mean that the point is included in our solution set. Perfect. But the second one here is x is less than 5. There is no equal to sign. So if there is no equal to sign, what we have here is a hole, not filled in circle. Open circle, right? So we also say this is an open circle. Perfect. And that will be represented on a number line as shown here. Perfect. So everything from 5 to the left of it. Correct? So that is what it means. Now we could have a boundary condition on both the sides, right? Those two will show infinite solutions, correct? It goes up to infinity, right? Now here we have a boundary. X is greater than -1 but less than 7. So we could have a double inequality. So this is the double inequality. So I hope now it is clear what do we mean by a double inequality. We are giving two conditions at that time. Perfect. So that means that x is greater than -1 and less than 7. So both -1 and 7 are not included since that equal to sign is not there. Correct? And on a number line, we'll show it with holes on the two sides. So open circles on the two sides, correct? Two ends of it in between all the set of real numbers are included in our solution, and that is how you write this. So I hope that is clear. Perfect. So let's move forward and now further explore. Okay, now let's talk about the compound inequalities. In these compound inequalities, we'll use the term and or. So, as we saw last time, if we have two conditions, that is x is less than 5 and x is greater than 2. So we are given here two conditions, right? So when two conditions are given to us, both should be satisfied. Now this is with and. So when we say and, then for example here, we have shown you x is greater than 2, right? So x is greater than 2. Let's color it in some different color, okay, blue. So that is x greater than 2. On a number line, we have shown this from in this direction, right? Going in this direction. The other one is that x is less than 5. That means from 5 onwards, we are going in this direction. Do you see that? What is common to both? That is what we mean. So what is common to both is shown here, is everything in between 2 and 5, not including them. You get the idea? So and means a continuous thing in between them. So we have boundary on both the sides. And we write this as a double inequality. Do you see that? So two conditions give us a double inequality. As shown here. Perfect. Now, of course, since the equal to sign is not there, the two ends are not included. So we could have these double conditions with and or with or, right? So when we say x is less than 2 or x is greater than 4, that means in our solution, it could be either of those ends. So as shown here, that is the or condition. Whenever we have or, you will see a split in the solution as shown here. And this will be written again with double inequalities, but both separated, right? So as written here, let me write it big and bold, that we are now writing as shown here, x is less than 2 or x is less than 4. Or symbolically is union. So our set combines both the things, and this symbol stands for union. And that is in a way or. Is that clear to you? And means intersection. Let me write down this symbol as intersection of the two, right? So we could write this as an intersection. So we saw what was common, that is the intersection. So you can say that and condition is like an intersection and or condition is like a union of the two. Perfect. So they could be poles apart, but they are all included. That is or condition. Perfectly fine. So that gives you a good foundation to begin with some examples based on inequalities. So let's take up the very first example, which is a set of 4. Okay, so here we really have 4 examples. The first one is 2x plus 4 is less than 10. Second, we have changed the equation, complicated with some rational functions, right? So you have a denominator here. How do we solve such an inequality? And then we have involved a switch in the type of inequality, and then we'll talk about something where we have distributive property to apply. So in the very first case, we're actually taking 4 wide variety of examples, and they will show you the techniques involved. Perfect. So we are going very fast. I'd like you to think about it. How do we solve these equations? Well, simple. We'll apply the same rules as we did in solving equations. So here we could take away 4 from both the sides, correct? So if you do that, you get 2x is less than 10 minus 4, which is 6. And now we could divide by 2 on both the sides, and we get x less than 3. Do you see that? That is how we are going to easily solve the inequalities. Now in this particular case, 2x plus 5 over 3 greater than equal to 7, what should we do? Perfect. We could multiply on both the sides by 3. So this 3 will cancel. We are left with 2x plus 5 is greater than equal to 21. So copy the same sign which is being used in the inequality. Keep saying it in your mind so that you understand these symbols. So we got 2x plus 5 greater than equal to 21. So of course now the next step will be, as you have seen We'll do -5, -5, and then we'll do divide by 2 and divide by 2 to get the answer. You got it. So I'd like you to actually solve these questions in this fashion. Perfect. I've only shown you the steps. Are these two examples clear to you? Yes? Okay. The next one. What do you think we should do in this particular case? Well, of course, in this particular case, I should do -5 first, right? So I'll do -5. I want to get rid of the numbers from the left-hand side. That is what we are doing. Same operations on both the sides. So when I do that, I'm actually left with minus x over 2, which is greater than 10. Now the negative sign comes. What should I do now? In this case, I have to now multiply by 2, right? Or -2. Then we'll solve further. Correct? When we do multiplication by -2, then what happens? The sign changes. So important thing here is first you change the sign when you are multiplying by -2, and then it becomes 10 times -2. Do you get this point? Remember, we said 7 is greater than 5. How about -7? -7 and -5, the sign changes. When you multiply by a negative number, the sign changes. That is a key. And this is normally a mistake. Sometimes the question is, find the mistake, right? So they will not change the sign, but they will multiply or divide by a negative number. It is very confusing. So that becomes the solution, which is x is less than -20. Is that clear to you? Perfect. That is how you have to do it. Now here also I have a similar situation. So when I open this bracket using the distributive property, what do I get? I get 3 times 2, which is 6, minus 3 times 5, which is 15, x plus x less than equal to 4 times x plus 8. Now we have a similar situation as we did in our question number 1. And then we can continue with the solution. You also note here that the negative number associated with x is bigger, the value 15, than 4 on the right hand side. So if you bring them to this side, in that case you get a negative number, and when you multiply by a negative number, you may have to switch the sign. Perfect. Correct. So in such cases, what you could also do is keep the variable on the right side and the numbers on the left side. What I'm trying to say here is you could actually, you have 6 here. You could bring this 8 on this side, correct? Maintain the sign. You have 4x there. You can take this on the right side. It changes with the sign as you learned in algebra. And I'm not simplifying, but just showing you how you could do it. But when you do like this, do you see all result will be positive here, right? So we do not really have to switch this side, right? So we avoid switching because of multiplication with negative number. You get the idea. So that becomes a different strategy. So that is kind of a strategy. So I hope you've understood these strategies, right? Let's look into it once again. So here is the solution of our first inequality. The very first one was 2x plus 4 less than 10. Now the step here is to take away 4 from both the sides. So when you take away 4 from both the sides, then what happens? We're left with 2x on the left side, and the right side will be 10 minus 4. So we could write this as 2x is less than 5. You note that in solving these inequalities now, since we have learned the technique while solving equations, we are going like direct, right? Instead of showing that take away 4 on both sides. Do you see a direct approach here? That's very important. Now next step also, when we have 2x is less than 6, we are again taking a direct approach, divide by 2 on both the sides. That is to say, we actually divided by 2 on both the sides. When you do so, then these 2's cancel and you're left with x on the left hand side and 6 divided by 2 on the right hand side. So instead of showing this step, we did as shown here, x less than 6 by 2. It really means divide by 2 on both sides. And you get your result, which is x is less than 3. Is that clear to you? So as you can see, we have skipped few steps. However, we have got the right solution, and this is the right way also, correct? You can skip those steps now, since you really understand it, right? Sometimes in the question it will be mentioned that you have to follow or describe each steps. That is a different case. But normally in solving inequality, you could do this, right? That is an option, right? This is an option that can be used. Is that clear to you, right? If not specified, you could use this option. This is what I'm trying to say. Now, x is less than 3. You can provide the solution in many different ways. Here, we have provided the solution in the set form. So, we have a solution in the set form. So, as you learn, the curly brackets means a set. So, we are saying a set of numbers where x belongs to all real numbers such that this is for a condition, right? X is less than 3. So once again, in the set form, I hope you remember, these curly brackets means condition, right? Means set of. And this bar here is the condition. And that means real numbers, right? R is for real numbers. So this is a set of real numbers. Perfect. So we are saying that the set of x belongs to the set of real numbers where x is less than 3 is a part of solution, correct? On a number line, how will you show it? So if I have a number line, let us say with 0 somewhere here. In that case, we are saying it is less than 3. Less than 3 means that let us say 3 is here. Then the solution is on the left side of 3. Okay? Less than 3. You see that 0 is included. So 0 is included in solution. Is that correct? So can we check, is it right or wrong? Let's check. We have the equation which is 2x plus 4 is less than 10. If I put 0 here, then this becomes 0 plus 4 is less than 10, or we get 4 is less than 10. This is true. And therefore, our solution is correct. That is what we call zero check. Is that clear to you? So, right in the beginning, you could also check it. Just substitute 0. You get 4 is less than 10, and we know 0 is a part of solution. So, therefore, when we are writing the solution, 0 should also come. It should be included. And that is kind of a check. You understand? Such a beautiful thing. Let's test here. So, if I put 0 here, let's do 0 test here first, right? So if I put 0 here, I get 5 over 3 greater than equal to 7. It is false, right? So it is not a part of solution. Not a part of solution. Is that clear to you? So we know that our solution should not have 0. Perfect. And you can see what the solution is. The solution is that x is greater than or equal to 8. Which does not include a 0, right? So the solution here is on a number line. If I'm trying to represent the solution, let us say 0 is here. We are saying it is filled in circle and on the right side. 0 is not a part of solution and therefore it is correct. You understand this part? So we have done the 0 test on the inequality and ensured that our solution is correct. Perfect. So I hope you have understood this, right? Steps followed are as discussed. So what we did was we multiplied by 3 on both the sides, getting 2x plus 3 greater than equal to 7 times 3. So that means that is 21. So we could write 21 directly and take 5 to the right hand side. 21 minus 5 now is on the right hand side of the inequality. So 2x is greater than or equal to 21 minus 5. And what is x? Divide by 2, get your result. You get the idea. Do you see, once again, we have again minimized our steps. 7 times 3, we wrote directly 21 in the next statement. So sometimes when, there are many steps involved, it is a good idea. Once you get practice, you could do like this. That is much faster. Perfect. And now you have understood. How do we solve these inequalities faster? Sometimes time is also a constraint, and the question is not asking for providing reason for every step. In that case, this is the approach which we can adopt. Perfect? Now let's look into what was the zero test. We did apply it, right? And now let's look into this zero test. It says, zero test is the fastest way to check the solution. Perfect? Just substitute 0 and check if it is a part of the solution or not. Substituting 0 in the first example shows that the inequality is true, as we can see, right? Inequality is true. And you can see that it is also a part of the solution. That should be correct, right? So it is a part of solution. We know 0 is less than 3, so it will be a part of solution. Perfect. Substituting 0 in the second example shows that the inequality is not true, and it is also not the part of the solution. Therefore, the solution is correct. So I hope the zero test is absolutely clear. Perfect. Now, let's move on just to see the solution of the questions which we took up and discussed. But I'd like you to solve them yourself. Well, here is the solution which you can just have a look at, and then when I share with you the copy of this video, you can go back and check your solution. The idea is you should be actually solving these questions yourself. So you should solve and check. Correct? And how will you check? You will check with zero test. Is it a part of solution or not? If it is, it should be there in your solution. If it is not, it should not be there in your solution. That is what the test is. Okay, let's move forward and take the other kind of examples. Now in these examples as shown here, we have verbal statements. So from verbal statements, we are going to write our inequality and solve them, just as we did earlier with equations, correct? So now we'll define variables, write inequality, and then solve. That's the exercise. And then we have to apply the zero test to check our solution. That's always there. Perfect. So normally it is not given to you. It is for you to do it. We are putting it there right before you so that it's in your mind that you should check your solution. Perfect. Question number 5 here is 3/4 of a number decreased by 2 is at least 37. So the word at least means what? This is very critical to understand. And 3/4 of a number. So that becomes a phrase. Can any one of you translate this phrase into an inequality? 3/4 of a number means? Right, you're right. 3/4 of a number, we are saying x is our number, right? 3/4 of a number decreased by 2, that is minus 2, is at least 37. So we have 37 on the other side. At least means it is 37, 38, 39 or more, right? Do you understand? At least. So it is greater than or equal to 37. That is the meaning of at least. You get the idea. So in the phrase, at least means it is more than or equal to. Perfect. Question number 6 is 15 is no more than 3 times sum of twice a number and 7. So I'll leave it up to you now. You write down your inequality. But let's discuss about is no more than means that is the maximum value it can go up to, right? Do you understand? So it is less than that value, right? So it is no more than, it could be that value, correct? So the inequality here will be less than equal to. You get the idea? So that is how you have to understand the phrases and write them as symbols. Perfect. And these symbols are inequality symbols, correct? Then we have a word problem. So most of the complicated questions involving inequality, word problems will involve these terms, at least no more and such terms. Now you understand how do we work with them. Perfect. Here is an example. A car salesperson is paid base salary of $40,000 a year plus 4% of sales. Find minimum sale for annual income of at least, you see that word, at least 70,000, right? So of course we have qualified with minimum sale. So that is kind of related. Do you see that? But since this is our initial example, we're trying to use the two words so that you could correlate them, right? So it has to be 70,000 or more. You get the idea, right? So that is how we are going to solve this, right? So as you know, first phrase, you learn some linear equations. A car salesperson is paid with a base salary, which is fixed. So 40,000 is fixed per year plus 4%. You could write 4 over 100, right? Or you could also write 0.04. That is 4%, right? This is for 4%, right? Of sales. So variable is sales. And this minimum income should be at least, means it could be 70,000 but greater than equal to 70,000. Do you see how we wrote an equation? That's kind of important to write. Once you write an equation, in the earlier examples, we learned how to solve the inequality, I should say inequality, then you can solve it. But the critical step is to first get the inequality itself. Perfect. So let's move forward and see how to solve these questions. So as I was saying, and as you got really, the question number 5 was 3/4 of a number decreased by 2 is at least 37. So 3/4 of a number decreased by 2 is minus 2 is greater than equal to 37. The second one was 15 is no more than, so we have written here, it's kind of critical. 15 is no more than means less than equal to, right? 3 times sum of twice a number and 7. You see that? Sum of twice a number. 3 times, so that is 3 times. Sum of twice a number and 7. So that is twice a number and 7 sum. So within the brackets, it's a very compound statement which you see, right? We have done this kind of statements earlier in equations and expressions. It comes handy to you. How many of you got this right? Perfect, that's great. So again, look at this phrase and then see how we got the right hand side. 3 times within brackets 2x plus 7, which means 3 times sum of twice a number and 7. So both are being multiplied by 3. You get it? Therefore, 3 is outside the bracket. So once you get that, you can actually find the solution. I'll encourage you to first do it on yourself and then see it. So first do it. So of course the steps are common. We took this minus 2 to the right side as you can see here, and then when we combine them, we multiplied by 4 divided by 3, the reverse operation, and got our result. On this side, we prefer to divide by 3 first, and we got 5 on the left hand side, took away 7 divided by 2. We got a negative number, and x is positive, x is greater than equal to 2. Now, can you write this on a number line? That is the solution. Your exercise is show solution on a number line. Is that clear to you? We have a solution here. written in the form of an inequality, right? So draw a number line here and then show your solution. Is that clear to you? That is an exercise for you. Perfect. Let's move forward. Example number 7. A car salesperson is paid base salary of 40,000 a year plus 4% of the sales. Find the minimum sale for annual income of at least 70,000. So minimum sale for 70,000. This is what we are interested in. We have defined a variable S for sales, and as we discussed, we can write down the equation. Fixed salary of 40,000 and the plus 4% of the sales, which means 0.04, right? 4 divided by 100 should be greater than equal to 70,000. Perfect. You can solve this and get your answer. So that becomes in dollars. So we'll write a statement here write a statement for solution. Perfect. The statement is minimum sales of this much, which is 750,000, is required for at least 70,000 annual earning. Perfect. Now let's see further examples. Now these are similar but slightly more complicated. Question number 8. Take this as your practice test, right? Okay. So one of you, can you please read this? Question number 8. 6 less than a number is no more than 14 and no less than 1. So it's a compound thing, correct? So we're talking about double inequality. You get the idea. And we have 6 less than a number. So the number is x minus 6. 6 less than a number is no more than 14 and no less than. That means maximum limit is 14 and no less than, and it is not less than 1. You get the idea? So on this side it is 1 and on this side it is 14. Correct? You have to fill in what inequality should come here. We are saying it is no more than and no less than. Can it be 14? That is what the question is. Not more than, right? So it could be 14, right? And no less than, not less than 1, right? So it could not be there, but it could be 1. You get the idea? And therefore, we have an inequality. You see. So that is how you have to translate to get to the equation. Now it is easy to solve. Question number 9 here is, the volume of water in the tank is recommended to be at least 5 liters, right? But not more than 24 liters. If the current volume of the water is only 2 liters, what is the recommended range of water that can be added, right? That is what the question is. I'd like you to pause the video at this time, look at it, and get your solution. Now, question number 9 is very similar to question 8. It's an application question for you. Perfect. So what we have seen here with these 9 examples, we began with very simple inequalities, understood the basics of moving the variables or the numbers, adding, subtracting, same things on both the sides, solving them, understanding the phrase no more than, not less than, greater than, equal to, and also representing the solution on a number line or in the set form. We also understood how do we perform the zero test, correct? So I'll leave this for you as a practice test question. You need to understand, write the inequality and then the solution. Perfect? So take your time to do it. Let's move forward to have a look at these inequalities. So as in the first case, I was saying the sign should be greater than equal to. So x minus 6 is greater than equal to 1 but is less than or equal to 14. That is, we are saying no more than means no more than 14, right? No more than 14 is this. You see that? So that is how it is. Now the question is, how do we solve a double inequality? Perfect. To solve double inequality, we do the same operations in all the three parts. So we do same operation. What are the operations? We do not want this 6 here, correct? We do not want this 6 here. So we'll add 6 to remove minus 6. We add 6 in all the three terms. Once you do that, we have isolated x right in the middle. We have 7 on one side and 12 on the other. So on a number line, if we have one here as shown, then the solution is between 7 and 20, and both are included. So we'll fill them up. You see that? We'll fill them up. So from 7 to 20. 0 is not a part of the solution, right? 0 is less than 1. It is not a part of the solution. And the 0 test clearly indicates that, well, 0 is not a part of solution and this is the right solution. You get it? So while we are solving such questions, so many things which we learn come in our mind. We can actually add to our solution as shown here. You get the idea? Perfect. Similarly, in the next example, which is question 9, again, we get a double inequality. We're saying the volume of the water in a tank is recommended to be at least 5. So this at least 5 is right there with an inequality greater than equal to, but not less than or but not more than 24 liters. So it could be 24 but less than 24, not more than. So 24 is included. Okay. If the current volume of the water is only 2 liters, what is the recommended range of water that can be added? Added to 2, right? So x plus 2. Very tricky question. Added to 2. 2 is already there. 2 liters of water is already there in the tank. If you want to make it 5, you have to add 3 liters, and that is the part of solution. You see that? That is how we have to solve the inequality. So I'd like you to go through these steps once again and understand how do we get the result. Clearly, what we did was, first, we want to get rid of this 2, right? Since we want to get rid of this 2, we subtracted 2 from all three of them. I forgot to write here, so minus 2 in all three of them. So it's 5 minus 2 is 3, plus 2 minus 2 cancel. We get x in between and 22 on the other side. And that is how you get the solution. Is this clear to you? Perfect. Let's move forward. Question number 10. Now here actually we are given two different inequalities and we need to solve them, right? We call this as compound inequalities. Example number 10 is to solve inequalities with and sign. And means common to both, right? So whenever there is an and inequality, so we'll see what is common to both, correct? Now in this particular case, find the set of values of x for which 2x minus 6 is less than x plus 7, that is one inequality, and 3x plus 5 is greater than x plus 5. So in a way, we have two different inequalities which I wrote here. This is the first one and that is the other inequality. We'll solve both of them and see what is the common solution. So for the first one, let's solve it here. We have 5x minus 13 equals to x plus 7. What it did was we brought this x on the left side, right? So let me show it here. We actually brought this x on the left side, right? And the number 13 on the right side. So we have variables on the left side. We can write this as 5x minus x less than 7 minus 13 becomes plus 13. 5x minus x is 4x, and on the right side we get 7 plus 13, which is 20. Dividing by 4 is x less than 5. You see that? So we got our solution x less than 5. This solution x less than 5 is shown here. So this is this part of the solution. Okay. Solving the other inequality. 3x plus 1 is greater than x plus 5. Bringing x on the left side, we have 3x minus x. 1 on the right side, 5 minus 1. 2x is greater than 4, x is greater than 2. So we get this as the solution for the second inequality. Now, we're looking for the condition which is and. Both the equations should be solved, and that is the common value in between them. Do you see this? That becomes part of our solution, which is a continuous solution between 2 and 5. You get the idea. That is how we are going to solve it. Perfect. And we have provided the solution in the set form. It is a set of real numbers where x is greater than 2 and less than 5. Perfect. I hope it is absolutely clear. So that's very complicated. We have actually solved two inequalities together to get our case. Now let's take one more, but this time with OR condition. Okay, so the condition here is OR. The question is, find the set of values of x for which these two inequalities, 5x minus 3 is less than 7 and 2x plus 1 is greater than x plus 5. They should be solved with an OR condition. Either this or that. That means we have disjoint solutions, right? We have a wider set of solutions. Either that is true or that is true. Both, right? Okay, so we solve each one of them separately, learn all the strategies, apply them. So first thing first, bring 3 on this side. 7 plus 3 is 10. Do you see that? 5x less than 10. Divide by 5, x less than 2. I'm skipping steps, but you can include all these steps in your solution. Perfect. So I'll say here, include missing steps. Is that clear to you, right? So as you learn, you should actually put in all details, which I'm not putting in here, that may be required. It is essential at times. Okay. The next one here is, we brought all the variables to the left side. Do you see that? Variable on left side. So that could be a rule. Bring all the variables on the left side and constants on the right side of the inequality to solve. Once you have two solutions, in this case, the solutions are x less than 2, which is here, x less than 2. The other one, x greater than 4, and both union is the part of our solution. Is that clear to you? You perform the zero test. If I write 0 here, I get minus 3 is less than equal to 7. Yes, that is true. So zero test. So if you perform zero test, you have here minus 3 is less than equal to 7, which is true, and therefore 0 is a part of our solution, as you can see. So that is correct. Perfect. So that is how you should do it. Now here is the last question which we are going to discuss. This time we have a double inequality which says that 2x minus 5 is greater than minus 7 and less than 9. I would like you to take this as a practice test. We have done similar inequality earlier, correct? What you have to do is, you have to find the set of values of x for which this, we also call it a linear inequality, is true. So it's a linear double inequality. Represent the solution on a number line. Write an absolute function inequality with the same solution as above. So this part of an absolute function we'll actually discuss in the next session. Perfect. So rest of the things I'd like you to do. Perfect. Now here is the next example. Well, that's the solution. Okay. Next example. Also, this is for you to explore. I'd like you to explore the solution for x squared minus 1 less than 0. Perfect. So what you could do here is you could graph. And you can also find algebraic solution. I will not discuss the solution here, which is before you, but that gives an idea, a hint. So this is just for your hint to do, correct? But this is kind of extended. We'll discuss this in our next session also. Perfect. Now let's have some practice questions. I'd like you to copy these practice questions and practice your skills so that we can move forward. And you know now, what are we getting into? We are getting into more complicated cases where we are going to look into absolute function inequalities, double inequalities, and inequalities involving quadratic equations. Right. But before that, we should ensure that we have learned whatever we saw today in this particular lesson. Perfect. So these are the questions for you. I'd like you to take a picture of this and then solve them on your own. So that is where we are going to end today. So the very first question is set of inequalities which have all types of things which we learned. A simple inequality as shown here, one with rational, one with distributive property, a double inequality. Perfect. So these are the different inequalities. Then we have verbal statements to work with. Two examples here. One of them is, and they have the terms, which is less than, and then compound statements right there, very complicated. So I'd like you to read them properly, solve, and submit your solution, right? So practice these inequalities. So with that, we come to an end of our first session on linear inequalities. In the next session, we'll actually look into the absolute function inequality and also the quadratic inequality, which we talked about, and take some more examples. I hope you enjoyed today's lesson. If there are any doubts, ask questions. Great. Thank you. We'll end it right there. And all the best.